Hey everybody, this is Larry. This is day 30th of the Leetcode Day Challenge. Huh, does this shit make me look naked? Anyway, the lighting is a little awkward. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this farm. Only 2 more days in the contest. Or in the contest, in the month. Maybe as a, anyway, okay. Not gonna make a joke there. I was gonna make like a couple of dad jokes. But anyway, alright. So let's get started. Today's farm is a hard one, supposedly. Or it probably is, but I'm just saying that's the label. 2366 minimum replacements to sort the array. Alright, let's go. Wow, end of summer already. Time flies, isn't it? Anyway, okay, so you're given a zero index array nums. In one operation, you can replace any element of the array with any two elements that sum to it. For example, nums is 5, 6, 7. You will replace num sub 1 with 2 and 4. Okay. Return the minimum number of operations to make an array that's sorted in non-decreasing order. Okay. I mean, I would. One thing I would just say, just in general, and maybe you already did because I did this. I'm doing this video in the morning because I was just out a bit late last night, so I didn't really get to it. But if you can actually watch, you can watch me solve this live during the contest whenever it happens. This probably happened. And I say this because the prom number is like in the 2000s, and I think I have contest videos on all of them. So you could see me actually solve it live during a contest and not just, I don't know, just in case you think I don't know. But I don't remember this problem, so it'll be solving it live here anyway and explaining it hopefully live. But if you're looking for maybe a little bit better for the because I think I explained it in a different format during the contest. So maybe that's better for you. Anyway, all right, that out of the way, let's take a look. All right, so you want a non-decreasing order. You want breaking away to non-decreasing order. Okay. Okay, 2 elements. I wasn't sure if you could do more. So okay, so the first thing to notice is that you can only break them apart. So that means that what does that mean? I don't know. I don't know. N is big enough, so it's not a. I guess the one thing that I was kind of considering, but not really, is some sort of n square dynamic programming algorithm. But saying that n is equal to 10 to the 5th, well, n square is obviously out the window. And a little bit of a, I mean, I wouldn't say cheating, but just like, you have to code your constraints, but it is a little bit of a hint, especially during a contest time, when you see n is equal to 10 to the 5th, because now you're thinking about O of n algorithms or O of n log n algorithms in general. Or, I mean, there are other algorithms that maybe run fast enough, but they're very rare for, at least like on Leetcode level, right? Like maybe there's some n times the square root of n algorithms, and union find, you can define it a little bit however you like. With the inverse Ackermann function, right? So, yeah, but that's it. These are the things that I'm thinking about, and in a little bit of a way, it makes it a little bit of a hint, is what I was going to say. It does simplify a little bit, because then now I'm thinking of and I'm thinking about my thoughts out loud because I don't know the solution yet, to be honest, right? So hopefully this is at least entertaining, maybe educational. But so what I'm going to be looking for is going to be some sort of n log n, n log n algorithm, and with that, what that means is, I mean, it could mean a number of things. There could be amortization, meaning something that averages something out. But the prime thing I'm going to look at or think about anyway, for now, I mean, it could be very wrong, and maybe I'm down the wrong path, is do some log n operation for each element as we go from either left to right or right to left. In this case, there's a symmetry to it, so it doesn't really matter. If you go left to right, you make it non-decreasing. If you go right to left, you make it non-increasing. So, so this is sort of symmetry, so it doesn't really matter which way you go. Or, I guess or the other way around, or whatever, depending on how your strategy is. But you can also make non-decreasing into non-increasing by, like, multiply everything by -1 or something, right? So it's not a so all these things are kind of equivalent in a way, and these are the things that I think about. Okay. Can you do greedy? Can you do binary search on the solution? That could be another thing that we think about. What would binary search on the solution look like? Just the number on the answer is what they say nowadays, right? Max number of operations, I guess. But you would just do it greedy anyway, right? Or at least the way that I'm thinking off my head. Well, what happens if you go backwards? Okay, I guess that's the way. I think initially I was thinking about going from left to right, but maybe it makes sense to go from right to left because you can only break things apart. I think that's the part that we kind of mentioned, and because you can only break things apart going from right to left, you know that the maximum number, right? Does greedy work in that case? Is that always true? No, because okay, I see. Because you can have a case that is something like or I mean, it may be. I think the idea is probably in the right direction. There's you can't just be like random greedy, I guess. Like, for example, you have a big number, you can have maybe a big number that's slightly bigger, and then, like, I don't know, 100, right? Maybe that's a poor example, actually. Maybe let's just say this is, I don't know, 5,000, whatever, that over 2. Then if this is even like 10,000, you would just break it all the way. Well, in this case, I think what I wanted to force was something like this, maybe. No, maybe like something like this. Okay, maybe something like this, where if you do it greedy in a way, then you would break it into. If you're not super slick on your greedy, you may break it into, say, 30,000, so one, and some one, right? And then now you have to break this further. Not to say that's not the right answer, right? It's just that this would be a greedy solution. And actually, I construct this because I am saying this is not the right answer, right? Huh. Yeah. No, I construct this so that this isn't the right answer. But in theory, even if I didn't know that, I don't know. Maybe I'm a little bit off today. But even if I didn't know that, the goal here would be to that this is greedy and we have to prove it, right? And here we actually, that's why I came up with this, was there's a counter example. Okay, maybe I'm off by one in the counter example. Oh, no, I forgot. What am I doing here? Well, yeah, you can do this, but then, I did them. Yeah, so this is what you want. I don't know, my math today. I just woke up, so clearly some stuff is a little bit off. But yeah, as you can see here, this would be the optimal solution. But if you do it naively, in a weird way, you would do something like that, and that's just not good. And that's of course to say that there may be, even breaking around 50,000. Like, if there are additional numbers, maybe it is more optimal to remove 50,000, right? So it's not actually clear to me that. Well, I mean, it's clear to me that this kind of greedy doesn't work because we just came up with a counter example, but it's not clear to me how to do it now. Can we think about this in reverse and like summing to it. I mean, in this particular case, we have to definitely. If we can break this to however we'd like. Oh, that's my stock market app, and I guess I forgot to turn off the sound because I usually do not do this at 9:30 a.m. But yeah, top of the morning to the stock market. Yeah, that's a tricky thing, right? Is I don't know that you can do this one at a time because the way to optimally divide this is not necessarily the optimal way to divide more than one numbers, right? Because maybe the next number, like if there's another number, I don't know. Or is there some independence thing that I could figure out? And what I want to say, and I don't know if this is true, is that it's possible, and this is part of the exploration, is that maybe there's some other number, I don't know if this is the number, where maybe that's not the right number, or at least it would make sense to break this into say 30,000, and then you break this into that, right? And in this case, actually, in both cases, or in this particular example, it doesn't matter. But there may be an example where that might, right? So I think that's the thing that I'm trying to think, right? On these are the things that are going through in my head. Is there some kind of like, and that's the part that I'm trying to think in my head whether, you could do it independently, because I mean, in another more extreme example, if you have say like some big number, you have some smaller big number, and then some bigger number. Clearly, you have to break this down first, and how you break this down will make a difference in how you break this down. So, am I talking too much? Because I'm not making any progress. Minimum number of operation. I mean, and also 10 to the 9, yeah. I just kind of had some DP solutions in my head that are like n square ish again, and I was just trying to think whether is there a solution. And sometimes I don't know if this is the case here because clearly I have no idea what's going on today. But sometimes it's like you can write a more naive dynamic programming or brute force or whatever, and then figure out a way to kind of see if there's a way to optimize out one of the dimensions. I don't think that's the case here, but that's why I was giving a very brief, a very brief thought. Maybe I should have slept a little bit more. Like, it's not clear to me. And one more observation is that you can always have an answer because you can break everything down to one, right? But no, it's perfect. I do wonder if there's a. I'm still thinking about graph rhetorics, and I don't think they're really. I don't know that they're in the same direction, but huh. And for this particular, for example one, I think that's the only solution, right? There's no other solution. So huh? Some days you just don't get it. My other dot keeps on going to like a heap related solution, but again, I cannot prove independence, and I'm also trying to figure out if there's a way to kind of do multiple steps at once, kind of thing, or like multiple numbers at once. But that's where I keep on going to the graph rhetoric of like thinking about them as path and weights and stuff like this, which maybe is fine, but that's not going to be n, or that's not going to be fast enough for n is equal to 10 to the fifth. Is there a DP? Can I do some DP and binary? Well, I can do binary search, but it's not naively. And maybe there's like a monostack thing to get the next number, but what happens if you do break it to this number? Well, that's the thing. I still cannot wrap my head around breaking numbers one at a time for this particular problem without, like, maybe I just have to think about how to prove it instead of, because I can't find a counterexample off my head right now, but something that is similar to this, but I am trying to. I'm tired. You know this is. Yeah, all those things are graph things. Yeah, I mean, if you haven't already, feel free at this point to skip ahead. Wow, we're only 18 minutes in. I've made no progress. I have no idea. I'm hesitating to kind of just, like during a contest, to be honest, to be frank, if I was in a contest and maybe even, if you're at home, I would say that I would maybe just try to get a wrong answer and then try to break down that wrong answer to see why it's wrong and then kind of learn iteratively that way. I think and during a contest, I think if you have no other idea, maybe that's just the way to go, right? Because during a contest, if you're not getting it right, then it doesn't matter, like you're trying to get it right. And if you don't have any idea, either there's whatever thing you have, even if it's not proved, either it's right or it's wrong. And if it's wrong, there's no penalty, right? Like if you don't get it at the end. But for me, I'm trying to figure out, especially here when I don't have time constraint. I mean, like I said, you should fast forward this. Then I'm trying to figure out. That would be kind of sad if it turns out to be greedy. Well, maybe it is greedy. But I think the going to right to left and breaking down stuff makes sense. But I think the way, but not in a naive way. I think you have to do it this way, because then that means that every number, because yeah, okay. I think you have to go from right to left because there's no because if you're going from left to right, in theory, your future decision can affect your past decisions, right? Or vice versa. But when you're going backwards to forwards, you have no choice because every decision you've already made is forced if you're doing it optimally, right? But then what was the case that I have? Something like this. Okay, so how do we check this? Like, how do we know what to break this down to? Right? Do we just break it down to 2? Well, no, I mean, well, constrained by this bit. I guess so. I guess you would, because you would always minimize. So I think now I'm coming around on a proof in my head, and I don't know that this is true, but I'm more convinced in that. Okay, let's say, if you have one operation, what can you do? Well, yeah, one operation. Then we'll do this. We always want to break this down as equally as possible, because then now it maximizes the. The distribution is even, so then it maximizes the front and minimizes the end. Yeah. But then the question is, of course, if we have one operation, that makes sense. If we have two operations, do we always want to choose two operations here, or one operations here and one operation here, right? I think that's the question. Like, because you wouldn't want to, in this case, go to something like, I don't know, what's it, 33, like that would require one here, right? But what if this is 60,000 or something, right? Then you can go half, but if you do go half, then now, because you know that you need two operations anyway. If you need two operations, you wouldn't break this into more. You would just break this into more, and that would have more of an impact, because then now the left side of this would be lower. So I think one of the top questions I get is, how do I solve greedy problems? And to be honest, as you can see, I struggle with them still. Not necessarily the coding or or coming up with them, but the proofs, right? And even just convincing myself. If I was more YOLO, maybe I would have done it already. But I think here now, I think using the incremental kind of idea, I'm a little bit convinced. So I don't know that I'm super confident, but at least I'm confident enough to kind of give it a try. And also, I think at a certain point, you know, it's debugging time. I have to figure this out, right? So yeah, like I don't know that I'm coming up with any new ideas, at least unless there's like some crazy algorithm that I wouldn't have done anyway. So yeah. So I guess technically we go start from n over 2 because we don't need n over 1. If num sub I is greater than last, and maybe set the last number to num sub n minus 1. Yeah, then we have to break this apart. How do I break it apart? So it's num sub I. So that's the number. We have to break it into. So this number of pieces, right? Let's just actually write this a different way. No, let's just keep it this way. So then I can write something like last equal to num sub I. So I guess I could just use zip or whatever. No, that's not true because this is not true. This is only true if this is true. That's why I keep on forgetting. Okay, so this is the number of pieces we'll break into, and I don't know if it's optimal, but it is an idea. So that's the number of operations, and then the last is just equal to. Oh no, this is not. Yeah, this is the number of operations, and then the last or the first number of that series is going to be just num sub I ops, and the rounding down would go down. And it's not. Okay, I need to write it a little bit differently. So current ops is here. This is for the current step. Right, and then in theory, this is the idea. Well, I can't even get this right. Oh, wait. So we break into 3 pieces, so it's the number of pieces minus 1, I guess. Yeah, I think I messed that up, but I mean, I knew that was going to work for examples. It's a very easy example to pass, but whether it works for anything more, I don't know. Yeah, let's give it a spin. We'll get a wrong answer and then we'll see what the, oh, really? I don't know what to say about this one. I mean, I definitely didn't really prove it definitively. And we end up taking 28 minutes. What did I do last time? I guess I did it the same way, pretty much. Instead of using last, I just updated the thing. Which is the same, exactly the same, pretty much. Except for I don't modify the input. Yeah, I mean, linear time, constant space, that part is obvious. I think the key part about this greedy is that, and I think that's the part I didn't appreciate, and probably spend like, I mean, if you've been watching, I think that's the part that I didn't appreciate is that if you have 2 operations, it is always. I mean, let's say you can get in, because I think the way that I would think about it is actually like this example, right? If you have 2 operations, even if this is, I mean, in this case it has to be actually, but even if it's here, if you have 2 operations to go, let's say there's another bigger number, I don't know, let's say you have some huge number in the front. Because, okay, I think I get it now. I don't think it's a strict proof, like mathematically, but I think the idea is that, in a way, I mean, there's some remainder and stuff like this, but in a way, you're trying to, you're starting off with some like a sub psi over 1, ASCII art maybe. So you have this, right? And you have, like, this is the series, right? That we're kind of looking at. And of course that we're trying to keep in increasing order, or trying to get to increasing order. And then the idea here is that if A2 is greater than A1 as an example, or the other way around, sorry, A1 is greater than A2, then we have to break this apart because there's no way to combine them, and these are, let's just say, these are good, then we have to break this apart. And in breaking this becomes bigger than that, or if it already is bigger, doesn't matter. If we're trying to do two operations, we can either do it like this, or like this, right? In theory, right? Then it always is more optimal to do it this way, because it minimizes the front end of this, like the yeah, I mean, I call it the front end because you break it into the way that I think about it is that let's say you have some number 1,000, then now if you break it into two, then you have 500 in the front and 500 in the end, or something like this. Or if you break it into three pieces, you have 2D3, 2D3, 2D4, or something like this, right? And in a greedy kind of way, this makes sense instead of try to figure out how to because basically if you're trying to have to do two numbers at the same time, you want to, and you always in a greedy kind of way want to minimize the number going outwards. But man, to be honest, if I'm not convincing, not gonna lie, that's because I'm not that convinced myself. Or I mean, proof by AC is not a very good proof, but and I do. I mean, I think there is some like property or observation that I'm not getting a good explanation for, or I'm not explaining very well. That's from just like years of experience, which is kind of like a crappy way of explaining it away. I'm not gonna lie. But I think that's kind of like the more of the visualization that I would think about it is that if you have to change like two steps, this will always give you a better arrangement, I think, than something like this, right? And because something like this, oh sorry, did I say minimize? I meant you want to maximize the left side so that more numbers can fit into the left side. I think I said it backwards. My bad. Oh my god. Yeah, maybe I need to take a nap. So that's why you actually do not want this to be as big as possible, and you want it to spread it out more, because then now if you spread out over two numbers, if you have two operations, the incoming side, which is the right side, you want that to be as big as possible, and then the left side, as small as possible, while maximizing the left side, right? And of course, that is if you break it down evenly. I think that's kind of the idea. I don't think that I'm doing a good job of explaining it. My fault. I don't know if I did a better job last time during the contest. How did I get a wrong answer? I just. Oh, I had like an off by one, it seems. How is this so slow? Today is much faster. What did I do differently? That's weird. That during the contest time is so much slower. I don't think I did. I mean, I know that I made some in place stuff, but. Oh, I go forward. That's how I do modification. But I mean, let's take a look at Torio. Maybe it makes sense. I mean, this is just argument, right? Like, I'm trying to see whether I figure out a strict proof. Like, all right, I mean, these are the things that we said about. And there's really no strict proof, is there? I mean, these are kind of the arguments that I'm talking about, but that's not really a proof. That's just, like they said, intuition. Is there like a proof? Hey. And it is a cute cat, but there's no proof. I think that's the part that I'm trying to. Hmm. Maybe. Yeah, I don't know. Anyway. Hmm. Yeah, much faster this time. I don't know why this is so slow. Anyway, that's all I have for today. Let me know what you think. It is a tough problem. I'm curious how I did during the contest. It used to be that you could click on this and then like you can kind of go to the contest or something, but I don't. Doesn't seem like you can anymore. And I don't know how to get back to contest, which is kind of sad because I feel like that was kind of useful for me. Not what is this? Missed what? Let's see if I can see what contest this is from. I'm just curious in general. I guess I'll just Google myself. That sounds kind of dirty now that I say it that way. But,
Hey.
it seems like I did it during the contest much faster, to be honest. But I also said that here, to be frank, oh, there's no link to the contest. Damn it, Larry. Bi-weekly contest 84. But I mean, I would say that I did say that. Whoops, I clicked on the wrong thing. That if this was a contest, I would have just YOLO'd, to be honest. But today definitely struggled more than the last time I did it. I don't think I was 55th, and if I didn't get that wrong answer, maybe still 55th. Maybe that 55th is a lie, or it doesn't include China or something. That's very weird that you go back and then it just doesn't. It's not true anymore. I don't know. 124. But yeah, I don't know. It's definitely a tricky problem to kind of prove, for sure. Yeah, and Josh finished tied for first on that one. Anyway, that's all I have for today. Let me know what you think. Hopefully you enjoy kind of my exploration into trying to do it the deliberate way. During the contest, I probably YOLO'd. I would have to watch the video to see what I did, to be honest. It's been a while. I'm old. I don't remember everything anymore. So yeah, that's all I have for today. Let me know what you think. Stay good. Stay healthy to good mental health. I'll see y'all later and take care. Bye-bye.